welcome you all on this wonderful platform that is BYJU'S exam prep. Please tell me, am I properly audible and visible to all of you or not? So guys, this is a very special session for vibrations. And guys, today we will be completing the vibrations conceptually as well as with some good numericals. But yes, as it is a brief revision session, we will not be going for the derivation part. Okay. So are we ready? Please tell me once again that voice is clear, audio, video, everything. Please tell me, guys. Everybody. And let me share the session so that other students can also join. Then we are starting it. Okay, guys. Okay, Prabhakar, Vivek. Yes, Jai Hind and good evening. So guys, we are starting now. So today's topic is vibration. The reason for taking this topic because of its weightage. Okay, because 4 to 6 marks you can expect from vibrations. Actually, previously it was coming for 6 marks for sure. Now we can say 4 to 6. Vinay, good evening. So moving further, guys, to the starting point. Today's topic is related to theory of machines and vibrations. And this is a topic which is also there for civil engineers as well. Okay. So guys, then I would be telling you about a new series before starting, that there is a rank up series which will be coming from 3rd of October. It means from tomorrow, where we are going to cover 500 questions. The theme is 250 questions will be done in the classes. Next 250 question you will be getting with answers as DPP, daily practice paper. The entire team will be coming up live for that. Malesh, good evening. We are starting the session. To get the PDF of this session, you can join my Telegram channel Mechanical by Dheeraj Sardana. And guys, this is a 2 days video which happened at 10 a.m. On this channel, BYJU'S Noida office tour, which me and Abhinav sir have taken. You can watch if you want to see how the work is going on, how the classes are going on, how the things are handled by all the teams in the BYJU'S office. So we are moving further. So we are starting, guys. So my dear, first of all, I would like to tell you vibration is a very severe issue in the mechanical systems. And it is treated like cancer in the mechanical components because it slowly kills the system. Like, you know, sugar, whenever a person gets the problem of sugar itself may not be a dangerous disease, but it is going to kill the systems of the body slowly. And that is why when a person is having sugar, it is very difficult to treat that person if he is having any issue with any of the body parts. So my dear, because sugar is similar to, like, you can say vibrations, vibration also weakening the immunity of the system. So it is becoming very difficult to, you can say, it is becoming very difficult because, as you know, yes, Vivek. So as you know, vibrations are going to reduce the immunity of the mechanical system. So it will be very difficult for working. So the strength of the system will get reduced with the time and failure will happen without any prior indication. So that is why vibrations are dangerous. So we need to study that. So before we study, I would like to tell you that when we are talking about vibration, a vibration system can have maximum of 4 things. Yes, Papa Gagoda, good evening. So I would like to say this is very important session. In 1.5 hours, we will complete the vibration. So just look at it, and if you are attending this session carefully, every question of the exam you will be able to make, because we are going to study it as exam oriented. Otherwise, I teach vibration for 12 to 15 hours in the classes, but this is exam oriented session. So my dear, a vibrating system can have 4 components. The first one is the kinetic energy storing device. So I feel everybody from childhood, you must have seen that kinetic energy is denoted as half mv square. Okay. And for rotation, we write it as half I omega square. So my dear, here both the cases, whenever you are writing this kinetic energy, this is mass moment of inertia. So mass is something which is going to store the kinetic energy. Anupam, good evening, bhai. Then my dear, second thing is the potential energy storing device. Now my dear, what is potential energy? You have studied from 11th class. So my dear, spring is generally going to store the potential energy. Okay. Generally, whenever we are talking about spring, we are going to show as a stiffness actually. Okay. So my dear, we are assuming that if this is a spring of stiffness S, then potential energy is half Sx square. You may be saying, sir, is that compulsory that every system will be having the spring? I will say no. Because when we say vibration or when we say stiffness, when we say spring, we want to say just stiffness. So stiffness is denoted by the spring actually. Actually, potential energy is stored in the form of stiffness, but we are denoting this with the help of spring. Okay, just for a notation purpose, nothing more than that. Then my dear, these two things are available with every vibration system. So these two are compulsory. They are always present. Okay, so as they are compulsory, they are always present. And if a vibrating system has only these two things, stiffness and mass, we call such a system as natural vibration system. Natural vibration system. Is it clear? Okay, Vineet. Okay, no issues. That's why thinking why you are not coming. So get well soon and we will connect on WhatsApp after the session. Okay. So my dear, the third thing which can be present in a vibration system is friction. Now my dear, whenever we are talking about the friction, we are not talking about the static friction. We are talking about kinetic friction. So it means relative motion I want to say. When I say kinetic friction, I want to say relative motion. So my dear, because relative motion cannot be shown by the static friction. So as I am mentioning kinetic, so relative motion, and which is best described by a damper, and it is denoted by C. Actually my dear, the technical name of kinetic friction is the damping. Okay, is it clear for everyone? Ajit, good evening. And my dear, the fourth thing, okay, before I go to the fourth thing, if a system is having these three things, then my dear, that system is said to be the damped vibration system. As it is having damper, it is also said to be damped vibration system. This is natural vibration system. And my dear, the fourth one, that is nothing but the unbalanced force. And you all always knows whenever we are talking about the unbalanced force, they are the forces which are creating the vibrations. These are the forces whose either magnitude or direction or both changes with the time. Okay, so such forces are said to be unbalanced forces. They may be coming from rotating or reciprocating component. Okay, so you may be thinking, sir, why we are not discussing about these two things? That we will discuss when we will start the force damped vibration. That what are rotating and what are reciprocating components. In other words, you can say unbalanced forces are nothing but the fatigue forces. Fatigue forces are those whose magnitude or direction or both changes with the time. And if any vibration system is having this unbalanced force, we call that as forced damped vibration system. We call it as forced damped vibration system. So my dear, here force is going to tell you about unbalanced force, damped is telling you the friction. So these two are the realities of the mechanical systems basically. And whenever these two are coming into the picture, system is becoming dangerous. Okay. So one by one we will move on. So guys, do like and share the session. So my dear, before we start this, the most important thing we need to discuss is the spring mass system. And if you will be understanding how this spring mass system is becoming, you will be understanding all the things related to natural vibrations. So in total, vibration is having three chapters: natural vibration, damped vibration, forced damped vibrations. Out of these three, natural vibration is going to have more importance, because damped and forced damped vibration is important for interviews. For papers, natural is more important, because in damped and vibration system, if you remember 10 formulas, you can solve any questions. But for natural vibration, you must have the understanding of the vibrations. That is the important thing. So guys, do like the session. This session is going to give you a lot of marks and you are going to learn a lot from this session. So we are moving further. So my dear, first of all, let us say we are having this spring, okay? And let us say this spring is having a stiffness of S. It is normally at this condition, this is the only spring. Then my dear, we are going to attach a mass with that. Because of mass, you know, the spring is getting deformed by some amount, and this is the mass at a new position. And my dear, now obviously when you will be attaching the mass, it will be deflecting. But after some time, you will feel the mass will come at equilibrium, and that is the position related to equilibrium. We call it as mean position. We call it as mean position. Till this time, there is no vibration, and you know, mass is deviated by some distance, that is delta naught. So we can call this as static deflection of mass. We will be using this thing in the Rayleigh method of natural vibrations. Okay, so you can call it as nothing but static deflection of mass. So I am going very nicely. I feel you are getting everything. This is static deflection of mass. So my dear, if you get this as static deflection of mass, now my dear, till now there are no vibrations. There are no unbalanced force, because we are studying natural vibration system. To start the vibration, we need to provide some external forces or some external disturbance. So we are providing some internal disturbance in form of X because it is natural vibration. So we are assuming there is no outside force. So we are going to displace this system by X. When you will be displacing it by X, then that position is said to be extreme position. Now, my dear, let us understand what was there at mean position. At mean position, your system was like that. This is mass, this is mg, and my dear, this is S delta naught. Now, what I want to tell you that body was in equilibrium at the mean position, so we can say mg is equals to S delta naught. Okay, so mg is equals to S delta naught, and here body is already in equilibrium. So, my dear, whenever you will be having a problem related to natural vibrations, okay, that is for sure, all the times, this mg weight is balanced by the initial displacement or deformation of the spring. So that is already balanced before starting the vibration. That's why whenever we study natural vibration, we never see the component of mg in such type of spring mass problem, because that is already balanced by the static deflection of mass before starting of vibrations. Then, my dear, we are coming to once again this time. At this time, when your spring is getting deformed once again, and my dear, we are reaching to this extreme position. Now, what is going to happen? Your system is displaced by some displacement X. So, my dear, if it is at this position, spring is getting deformed. Previously, you were having mg is equals to S delta naught. But now, my dear, when the mass is getting down by X, now, my dear, the downward force is still mg, but upward force will be now S into delta naught plus X. So we can write that, first of all, here, that we already know that mg is equals to S delta naught. So mg and S delta naught are already balanced. That's why all the time, whenever we see that we have displaced the system by X, we show a restoring force like that, that is S into X. Okay, because S delta naught is balanced with the mg. So that is how we will be denoting the system. So you can say at this condition, this mass is having a force acting on it, that is restoring force S into X. So because of this force, this mass will move. Although here velocity of the mass is 0, but this will move because of this force. And when it will be moving in upward direction, X will reduce. So because of that, the force will reduce. So slowly acceleration will be reducing, but velocity is increasing because of acceleration. And when mass will be reaching to the mean position, once again the X will become 0. So at this position, the force, restoring force will become 0. So acceleration will be 0, but velocity is maximum here. So because of this velocity, it will continue to move and it will reach to some new position, and that new position will also be X away in the opposite direction. Now spring is getting compressed, so spring will be applying force in that direction. So it is going to be a deceleration or retardation. And because of that retardation, because of this retardation, my dear, because of this retardation, the velocity of mass will be reducing, and at one instant it will be coming to the rest. And once it will be coming to the rest, once again this will be going on. So you can say at this position, the spring is maximum deformed. At this position, mass is having the velocity, but spring is not deformed. So we can say at this condition, spring is having the potential energy. When mass reaches here, that potential energy gets converted to kinetic energy of mass. When it is reaching here, once again kinetic energy converted to potential energy. As there is no loss, no friction, so total energy of the system will remain same. So my dear, this mass will continue to move like that, and this motion from this extreme to this extreme about this mean position is said to be vibrations. And whenever this is in vibration, this mass is going to follow the simple harmonic motion. That's why vibration is closely linked with SHM. So we are using the governing equation of SHM in the vibration. I hope you guys are getting everything, guys. Okay, full screen is not visible. Sorry for that. I didn't see your message. And Abhinav sir is also there in comment section to motivate you. Okay. Vijay sir, there will be before get. Definitely Vijay, it will be there for all the subjects. Okay, no issue, Vinay. For this particular instant, I am going to show you. Just look at it. Okay, now can you see? Now can you see? Please tell me. Now can you see whatever I told you? Yes, everybody understood now? Wonderful. So guys, if you want to take screenshot of that, you can take, otherwise I will share you the PDF. So I want to say here the total energy will be in the form of kinetic energy of mass. Here potential energy of spring. Here total energy will be in the form of kinetic energy of mass. Here potential energy of spring. So that way energy conversion will go on. Is it clear for everyone? Very good Malesh, very good Anupam. So especially Malesh, you requested me to take the vibrations theory part, otherwise I was thinking to take only the numericals part. So now I am taking theory, so you need to support by remaining live in the session. And guys, actually I was thinking ki generally you guys are also free on public week holidays or Saturday, Sunday. So we will be keeping the marathons like that so that you can revise the complete topic with me here. Okay, so if you want for any topic marathon, you can message in the comment section, Telegram group, WhatsApp group, personally to me. We will be coming with that. Okay, and thanks for your support guys, the way you are supporting, the way you are joining in the maths classes also. As I am teaching after 8 years, you may be facing sometimes issues with some of the concept I am teaching you, but I am happy that the response you are giving, and I will also try to give you better and better every day. Okay, so thanks for that. हाँ, numerical है भैया, numerical बहुत अच्छे हैं, numerical बहुत अच्छे हैं, ठीक है. Ishwar, good evening. Let's move further guys. So this was the explanation for the natural vibrations we have seen. Okay, so guys, is it clear for everyone? It is clear for everyone, fine. So guys, we have already seen that somewhere we are going to take the help from the simple harmonic motion. Okay, so guys, let us see now. So we have already mentioned that there is the equilibrium position which we call as mean position. So there are some definition we need to talk about. If you see, whenever we are talking about the mass, this is the mean position, this is the extreme position. So my dear, when we are talking about mean position to extreme position, this distance is said to be the amplitude. So maximum displacement of the system is said to be amplitude. And whenever this mass is going down, coming back, going up, coming back, this is said to be one cycle. And my dear, the time taken by one cycle is said to be time period. And the number of cycles per unit time is said to be the frequency. Everybody understood the basic definitions? Then I am going to explain the SHM to you. Okay, so let's move further guys. So my dear, now we will discuss about the simple harmonic motion. So my dear, when we are talking about the simple harmonic motion, I always told you in the theory of machines that there are only two types of basic motions. One type of basic motion is pure translation. Other type of basic motion is pure rotation. Other than that, whether you are talking about pure rolling or you are talking about any other motion like SHM, they are coming from the fundamental types of motion like pure translation and pure rotation only. Like let us say we are having a small ball in the circular motion. So when this ball is moving in the circular motion, if you take its projection on any of the diameter, like let us say I am taking the projection on this vertical diameter. So my dear, its projection will be coming here. I will be showing it by different color. Let us say the projection is shown by green color. This is the projection. So likewise, when this ball will be moving like to this position, 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 and will be completing this cycle, then my dear, I will be showing you the motion of its projection. The projection will be moving like this. Projection will be moving like this. So initially it is going like this. Then my dear, it will be coming back. It will be coming back. Here it will be at this position only. And once again it will be like this. So you can see when this is moving from this to this position, the projection will move like that. When it is moving from this to this position, projection is coming back like that. When it is moving in this to this position, projection is coming like this. When it is moving back to this position, it is going like that. So you can see this motion is SHM. So we are getting the simple harmonic motion by taking the projection of a ball, which is in pure circular motion, So the projection of the ball in the circular motion we are taking on any of the diameter is looking like what? Is looking like simple harmonic motion. Now we will derive the equation for simple harmonic motion very easily. I will not be deriving all the derivation. This is the basic one, so I am deriving. Otherwise, we will be going with the formula only, because it is wastage of time for gate to derive all the formulas again and again. So let us say this ball is moving with an angular velocity of omega and it is moving at this location. Okay. So my dear, you know r is the radius of this circle, and let us say in time t it is reaching to this position, so this angle is theta. So we can also write omega is equals to theta by t. So from here we can write theta is equals to omega t. Let us consider a situation that the ball is moving on this circle and we are taking the projection on this diameter. So you know that this is going to be the maximum displacement r, that is equals to radius, and at this particular the projection will be coming here. So let us say this x is the displacement of this ball. Displacement is always taken from the mean position. So we can write that x is equals to r cos theta. Yes, we can write this is r. X is equals to r cos theta. And you can also write it as r cos omega t. So as I am taking on this, I am getting in terms of cos. If you will be taking on this, you will be getting in terms of sine. So you can get in both the ways, because the point is it is shown by the harmonic functions. So that's why I am taking with different r cos omega t. So once you get this r cos omega t, you want to find out the velocity, you just need to differentiate it. You will be getting minus r omega sine omega t. And whenever you will be going for acceleration, you need to double differentiate it. You will be getting minus r omega square cos omega t. And you already know r cos omega 2 is x. So you will be getting x double dot minus omega square x. So the equation will be x double dot plus omega square x is equals to 0. This is the governing equation of SHM. But you know in vibration system is also in SHM. So we can say it is the governing equation of natural vibrations as well. And here omega is said to be the frequency. Omega is said to be the natural frequency of the system. Natural because there is no damper, there is no unbalanced force. Please tell me everybody got it or not. Guys, do like and share the session. इतना खराब तो नहीं पढ़ा रहा हूं मैं कि 50% लोगों ने भी like नहीं किया है. Is it clear? Are you getting it? So have you seen the relation? Now my dear, we are going to speed up by going into the methods directly. So my dear, we are going for method of calculating the natural frequency. Okay. So my dear, first of all, we will be going for the D'Alembert. We are not going into the Newton's method because we are not going to use it. We are going to use either D'Alembert method or energy method or Rayleigh method, torque method. So all those methods we will discuss. So what was said by D'Alembert? D'Alembert said, if this is the condition at extreme position, you can see Sx is the restoring force. Then D'Alembert said, add my component to the restoring force. What was his component? Inertia force. What is inertia force? M into A. What is acceleration? X double dot. So you can say his component was mx double dot. He said, add my component into the restoring force, equate it to 0, get the equation of Newton. What is that equation? That equation is mx double dot plus Sx, equate it to 0. This is the equation of Newton. So my dear, if you see this equation, now we need to compare it with the equation of SHM. What was that? X double dot plus omega square x is equals to 0. So can I say if this is mx double dot Sx, it is x double dot omega square x. So we can write this equation as x double dot plus s by m into x is equals to 0. Now with comparison, we can say omega square is s by m. So from that we can say omega is square root of s by m. So the final answer will be coming out to be omega n is square root of s by m. And my dear, this s by m is the natural frequency of vibration. If you want to find out in terms of hertz, you can write it as 2 pi into square root of s by m, because you know that it is omega n by 2 pi. Everybody understood the D'Alembert principle? Please tell me that. Everybody understood that D'Alembert principle? Please tell me that. Everybody got it? आ गया clear समझ में? Yes. So this is the D'Alembert principle, and we are going to use it again and again. The my dear second method is the energy method. First of all, I would like to tell you that when we are talking about D'Alembert principle and Newton's method, they are almost similar. If you want to learn Newton method, I am giving you a hint for Newton method. What we do for Newton method, what we say is that this is the mass, and we are saying it is displaced in the x direction, and we are writing the restoring force Sx dot. Sorry, Sx. Okay. Then we are writing like key, you know, it is going in this direction x. So we are saying that the accelerating force of this mass, which is m into a or m into x double dot. So this is accelerating force, in the displacement direction. So my dear, you can say this is mx double dot. What will be the restoring force in the displacement direction? This is Sx. In the displacement direction, it will be minus Sx. So it is minus Sx. Okay. It is equals to minus Sx. So what is that Newton equation? That accelerating force of mass is equals to the restoring force in the direction of displacement. So in the direction of displacement, it will be minus Sx. So you will get mx double dot is equals to minus Sx. So once again, you will get the same equation, that is mx double dot plus Sx is equals to 0. Choice is yours, which method you want to use, you can use. But I will say go for DLM, easy to understand. No need to reverse the direction of Sx again and again. Okay, so better to use it. Now we are talking about energy method. First of all, for Newton method and D'Alembert method, there is no limitation. You can use it in natural vibration, you can use it in damped vibration, you can use it in force damped vibration. But whenever we are talking about energy method, this is going to consider the energy of the system to be conserved. So it is assuming that the total energy of the system is conserved. I am not talking about the universe energy, that is always conserved. But system energy will be conserved only till the point friction comes into picture. So till the point there is no friction in the system, energy of the system will be conserved. Is it clear? So my dear, if there is no friction in the system, energy is conserved. So energy method is valid only and only for natural vibration system. Once you go for damped, once you go for force damped, natural vibrations is the only topic where you can apply the energy method. So I can say this is for natural vibrations only. Everybody understood the reasons? Because here we are assuming there is no friction present in the system. So my dear, if you say a spring mass system, I am telling you what this method says actually. If we are having this is mass, this is spring. Then my dear, you already know, if we are talking about the potential energy of the spring, you are writing it as half Sx square. If you are writing the kinetic energy of the mass is half mv square. Then my dear, what will be the total energy of the system? It is going to be kinetic energy of mass plus potential energy of the spring. So when you will be going for the total energy of the system, my dear, that is going to be is equals to half mv square plus half Sx square. You can write velocity to be x dot. So we can write half mx dot square plus half Sx square. Now you are saying there is no friction in the system. If no friction, energy is conserved, so dE by dt, rate of change of energy with respect to time will be 0. So we can say dE by dt is equals to 0. So what is dE by dt? 1 by 2 m for 2x dot into x double dot plus 1 by 2 s 2x into x dot is equals to 0. And my dear, then you know that the x dot value, x dot is common, we will make it cancel out. 2 will get cancel out, 2 will get cancel out, and you will be getting the equation to be mx double dot plus Sx is equals to 0. So my dear, can you feel it? You got the same equation. But you tell me, don't you feel D'Alembert method was better for this case? Because here we have done so much thing. D'Alembert was giving answer like that for this case. Yes, it is. Then why I am solving with this? Dear, I am just solving this to tell you that this method can also be used for this. But every method has some speciality. You can use any method for natural vibration, D'Alembert, energy, Rayleigh, torque, whatever. But every method has some speciality. Like energy method will be giving you answer fastly if you are having the cases of pure rolling, or if you are having the spring which are not massless. Because when spring will not be massless, they will also be storing kinetic energy. Because they have mass, they will store kinetic energy. So for these types of cases, when we have pure rolling motion, when the springs are not massless, then we are going to use energy method. So natural vibration is a tricky chapter. Why? Because here you need to learn which method will be giving better answer for which cases. So I will be taking one case of every type, okay, to explain you. Then I have 10 beautiful questions for you. You will love those questions. Is it clear for everyone? Is it clear for everyone? Please tell me. Please tell me, guys. Are you getting it? Are you getting it? Yes, yes, yes. Fine, guys. Fine, guys. Okay, great. So my dear, this was the energy method. As I already told you, energy method gives us better answers. Energy method gives us better answers when when we are going to have pure rolling motion. So I will be taking an example of with the pure rolling motion to make you understand nicely. So let us take that. Okay, let me see the empty slide. Okay, then we will go for relay method also. Okay, guys. Okay, so I am talking about a case when I am having, just look at it. We are having a spring and we are having a disc. It is mentioned that this is disc with mass m and radius r. Okay, and my dear, this is the spring with stiffness S. So my dear, whenever we are saying the pure rolling motion, everybody is aware that here, this is going to rotate with omega. The motion is going to be pure rolling. And you know, whenever here I will be writing the potential energy of the spring, it will be simply half Sx square. But when we are talking about the kinetic energy, when I will be writing this time, the motion is pure rolling. I feel everybody is aware that pure rolling motion is the combination of two types of motion. One is pure translation, other is pure rotation. Okay, so that also we have discussed a lot of times. So my dear, what is the kinetic energy of translation? Half mv square. What is the kinetic energy of pure rotation? Half I omega square. So my dear, this is half mv square, half I omega square. So my dear, you know that we can also write V is equals to R omega. So if we can write it, it is going to be half m. V is nothing but R omega ka square. And then we can write half, what is the I of disc? Mr square by 2. So it is Mr square by 2 into omega square. Now, as you know, V is equals to R omega. So you can put R omega is equals to V as well. So I can write it as 1 by 2 mv square plus 1 by 4 mv square. So you can write it as 3 by 4 mv. V can be written as x dot ka square. So my dear, in that way, you know the total energy of the system. It is half Sx square plus 3 by 4 mx dot ka square. So when we are saying this, my dear, you know dE by dt we will be doing as equals to 0. So when you will be doing that 0, it will be 1 by 2 into S into 2x into x dot plus 3 by 4 into m into 2x dot into x double dot is equals to 0. So my dear, you can see 2 will get cancelled out, 2 will get cancelled out. So you would be having that x double dot, because x dot will be common. X double dot is equals to, it is 2s plus 2s by 3m into x barabar 0. So from here you can compare x double dot plus omega square x is equals to 0. From here the natural frequency of the vibration will be 2s by 3m. Now my dear, you know they can change this question just by changing the body, because mass moment of inertia is different for disk, different for ring. It is different for solid sphere, different for hollow sphere, different for solid cylinder, different for hollow cylinder. So if we will be changing the just name of the body, the question will change, answer will change. Everybody understood that? Everybody understood that? So my dear, if that is the case, it is wonderful. So we understood this thing. This is about the energy method. Then my dear, if you are going to take the spring is also having the mass. So as I said, we will not be going for the derivation all the times. So I am telling you, if you are going to have a spring mass system only, but the spring is also having the mass. Ms is the mass of spring, m is the mass of block. Then the natural frequency of the system will be S by m plus ms by 3. So this is going to be once again from the energy method. So for energy method, the application is when we have the pure rolling motion, when the spring is not massless. Okay. Then my dear, we are moving to the relay method. Relay method is also based on the energy conservation of the system. Like there you say total energy is equals to constant. है ना? So and dE by dt was 0. Here we say that maximum kinetic energy is equals to maximum potential energy. Yes, it is. Because energy conversion is going on in the natural vibration. At extreme position, we have potential energy. At mean position, we have kinetic energy. So energy conversion is going to take place. So that is why we are equating this. So this is also valid only for natural vibrations. So this is also valid for natural vibrations only. So my dear, if that is the case, now let us see what relay method says. So if you remember, my dear, you have done in the first slide this case that mg is equals to S delta naught. So I am going to take this only. When you take mg is equals to S delta naught. So my dear, from this mg is equals to S delta naught, you can find out the value of delta naught. Delta naught will be coming out to be mg by S. Is it correct? Yes. Okay, I feel you may not be able to see this. So I am writing here only. So my dear, if you are having a spring mass system, so you already know that at mean position, downward force is mg, upward force is S delta naught, where delta naught is static deflection of mass. So when you will be equating mg is equals to S delta naught, then my dear, delta naught will be coming out to be mg by S. You will be getting it as mg by S. This is static deflection of mass. And what this method says? This method says no need to make the governing equation. This method says no need to make the governing equation because natural frequency can be written directly as square root of g by delta naught. So when you are saying g by delta naught here, delta naught is always static deflection of mass. So if you know the value of delta naught for any case, you can use this method. So if you ask me, sir, when we shall go for Rayleigh method, the identification for that is if you have a point mass, only one point mass. If two bodies have masses, then you cannot use it like that. So you must have a point mass. That is the first need. Okay. So if you want to use this method, Rayleigh method, you must have one point mass. And when I say point mass, there shall not be any distributed masses. If point mass is there, you can use this. If distribute mass is there, like a rod of mass m, a disc of mass m, then this method cannot be used. Second thing, it can be used only in natural vibration. So friction should not be there, damper should not be there. Okay. So these are the things when this method will be applicable. But here the thing is very easy. You just need to find out the static deflection of mass and you will be able to write the answer. So guys, now I have discussed these methods with you. Now are you ready for 5 to 6 questions? And in those questions, I will be more elaborately telling you about the Rayleigh method because those are going to give you better feel. Okay, are you ready for the questions? I will take one question from my side. Then I have 6 questions from wonderful sources. Okay, we will do those 6 questions, which will be covering all the methods for you one by one. Are we ready? Yes. So my dear, this will be a very effective revision for all of you guys. Okay, so we are going to start it. So guys, one question first we will do from my side because after that only you will get better feel of those difficult questions. So my dear, I am having this. There is a rod. There is a rod. Okay. This rod is massless. And I am saying that here I am having a mass m. Here I am having a mass m. And my dear, then I am having a spring of stiffness S here, like that. Okay. And this distance is A. And this distance is B for the mass. And he is saying that find out the natural frequency of the system. If you see this system, just by looking at that, first tell me, is there any friction? It is natural vibration, damped or force damped? Which system it is? Is it natural vibration system, damped vibration system or force damped? Which system it is? Which system it is? Natural vibration system, damped vibration system or force damped vibration system? It is natural vibration system. So definitely I have options with all the methods. Newton, D'Alembert, energy, Rayleigh, every method can be used. But then I remember Rayleigh method is the best one. I need not to make any governing equation, but I must have point mass. And this rod is given massless. So it is point mass, only 1 m is there, point mass. So my dear, I can go for Rayleigh method. What Rayleigh method says? Static deflection of mass. Static means before starting of vibration. So I need, actually the omega n is given as square root of g by delta naught. So my dear, when we have g by delta naught, like if you see where I have done it, we have done it here, we have done it here. So when you are saying g by delta naught, when you are putting this delta naught, what you are getting? You are getting mg by s. So you know gg will get cancelled out and you are getting the same answer, s by m. So if you are getting the same answer with that, it means I can use it for all the cases. I have shown this for spring mass, but I can use this for all the cases. So if I am going to use this method here, I just need anyhow delta naught value. If I am able to find out delta naught, I can get omega n very easily. Is it clear? So my dear, I need static deflection of mass. I know because of this mass, this will be having a tendency to come down. And you will see without any disturbance, I'm just looking the system from a far away distance. I'm not even touching the system. And you will see that because of this mass, this rod will be deflected like that. And you will find the mass 2 at new position. That is happening because of mass, weight, okay? So this mass is at this position. So this is said to be the static deflection of mass, which I will be denoting by delta naught. That I need to find out. This is without any initial disturbance. And I know because of this, the spring will try to hold this rod, but at the spring is deformable body. Spring will get deflect by some amount delta 1. Now, my dear, if you can feel it, there are two triangles, my dear. One triangle is this small one, and other triangle is this big one. And both the triangles have one angle common, other angle 90, and third angle will also be equal by angle similarity. I can say this delta 1 by A is equals to delta naught by B. And I am interested in delta naught, which is equals to B by A into delta 1. So my dear, as you are in mechanical engineering from 1 year, 2 year, 3 year, or how many years, you would be aware of one thing, that if in a question which is related to design part, maybe it is mechanics, SOM, TOM, MD, anything, if any hinge point is coming, I have to use this hinge point by taking the moment about that to be 0. So let us say this point is O. I am going to take summation moment about O to be 0. You know this mg will be coming downward, which will create a moment clockwise. I can write mg into B. Then as the spring is deflected by delta 1, there will be a restoring force. What is that? This is S into delta 1. This is going upward, will be creating anti-clockwise moment. So I can write minus S delta 1 into A is equals to 0. From here you can say delta 1 is B by A, mg by S. So my dear, I just need to put this value here. I will be getting delta naught as B by A ka whole square into mg by S. Once I am getting this, my dear, I just need to find out omega n, which is G by delta naught. So if it is G by delta naught, I will be getting the answer to be G by, what is delta naught? It is B by A ka square into mg by S. G cancel out. I will be getting A by B. Sorry, I forget. S by M into A by B. A by B is outside the root. I feel everybody got it. Please tell me guys, say something. कुछ कुछ कहते रहिए. जब आप कुछ कुछ कहते रहेंगे तो मुझे अच्छा लगेगा. Are we getting it? Please tell me guys. Are we getting it? Are we getting it? Are we getting it? Ishwar, Malesh, Ajit, Vinay, Malesh. Dear, actually, when the result will come, I will definitely put. Okay? GP Adarsh, when I will get the update, whatever the results are coming, notifications are coming, you know, I always come and make a video on that. And yes, I forget to tell about the IRL exam, that how it was. Exam analysis we have not done, but otherwise I give all the updates, guys. So don't worry about that. Okay? I will tell you once the result will come. So guys, this was the relay method. Now, my dear, we are entering into the questions. And my dear, before we enter into the question, one more thing I would like to tell you, in which the students are having doubts. Degree of freedom of a vibration system. Degree of freedom of vibration system. Degree of freedom of vibration system. So today's question, if you are going to attend, you will love them. This is my guarantee. Okay? And when we are talking about degree of freedom, my dear, degree of freedom is that number of variables which are required, or number of coordinates which are required to define the motion of a vibration system. Like if we are having a spring mass system, then my dear, you know that we are defining the motion of mass with one variable x. Yes, it is. Then my dear, this is degree of freedom 1. If we are going to have a simple pendulum, then my dear, you know, its motion is denoted by theta. So only one variable, degree of freedom will be 1. But my dear, if we are going to have like this is one mass, another mass, m1, m2. If this mass is going down by x, you cannot take guarantee that this mass will also be going down by x. Why? This spring will deviate. So because of that, if it is x1, it may be x2. So degree of freedom is 2 because two variables are required. Similarly, my dear, if we are having this, then we can have one more thread, one more ball. Okay, I'm showing upward, you may be facing difficulty. I'm having one rod, one more thread, one more ball. So you know theta will be this motion, phi will be this motion. So that's why degree of freedom will be 2. Similarly, my dear, more the motions, more the degree of freedom. If we are having a beam like this, and you know this beam can be divided into n number of parts. So this beam is deflected like that. So for this part of mass, this will be deviation. For this part of mass, this will be deviation. So likewise, we can divide this complete beam into infinite parts. So degree of freedom will be infinite. So for vibration system, there is no maximum limit of degree of freedom like 6. Here we can have infinite degree of freedom as well. So any number of degree of freedom is possible here. Like let us say we are having a spring mass system like this. On this mass, you are having a thread and ball. Then the motion of block will be denoted by x. Motion of ball will be denoted by theta. Degree of freedom will be 2. So my dear, the number of motions, the number of variables required to define the motion, that is telling us the degree of freedom. Are we ready, guys, for the question? Please tell me now. Now we are going to start some questions. Are we ready for that? Are we ready for that? They are wonderful questions. I am damn sure that you will enjoy them. Are we ready? Are we ready, guys? Please tell me that. Okay. So I got the permission. Let's move further. This is the very first question. Tell me the degree of freedom of this system. Tell me the degree of freedom of this system. You can see this is the block. This is the block. This is spring of stiffness S1. This is spring of stiffness S2, spring of stiffness S3. Okay. So can you tell me what will be the degree of freedom of this system? Are you able to see the system? What is the degree of freedom? Options are 2, 3, 4 and 0. Try this. Yes, Prasanna. Good evening, dear. Ishwar said 4. Malesh said 4. Vinay said 4. All are masters in degree of freedom. Ajit, you also say something. Malesh, GP, Adarsh, Ishwar already have answered. Okay. Tell me. Yes, Prasanna, try to answer. Okay. No issues. I am telling you. The answer is correct, 4. My dear, you know this block will be moving by some distance. For that, I need one variable x. This pulley will be rotated by some angle. If this spring will not be there, then x and theta would be surely having the relation. If this spring would not be there, then my dear, this would be going as per the x only. Then my dear, I will not be showing it with the second variable. But as you know, because of this spring, the movement can happen, the displacement can happen, deformation can happen. So here I need to show with different variable. Then once again, one more spring. Because of that, this can go down and up more than theta. So here I will be showing the motion by phi. Then the same, because of this spring, it can also have motion different than this. I am showing it with psi. So we are having 4 variables: theta, phi, psi and x. One linear, 3 angular. Answer is 4. Everybody understood this? Please tell me that. Sure, we will do that. Sure, Sakale, we will do that. Right now, actually, one material science marathon I have taken on this channel. You can watch till that time. It is available. That also a very detailed one. Okay, guys. Now, this is the question from Rayleigh method. Will you try this? This is the question from Rayleigh method. Will you try this? This is the favorite of gate. Rayleigh method is the favorite of gate. Here I am giving you a hint that because of this mass, this beam will be deflecting, and this is the deflection. and this deflection will be acting like the static deflection of mass. So as I said, some cases we will be covering in terms of questions, then only we can complete vibration in 1.5 to 2 hours. Okay, try to answer this. भैया सब होंगे, पापा का घोड़ा 1 by 1 सब होगा, किसने कहा नहीं होगा, but 1 by 1 होगा ना. Like today we have vibration, next week we have something else, we will have everything, don't worry. You just follow me properly in every session, because I am going to take the number of sessions based on your attendance, because I have seen if I come regularly you guys are not very serious, because whenever we get something for free very easily, we have less respect for that. So if you will be available, I will be coming up that much number of time. I don't have any problem. Okay, I will be coming up for all the subjects if you want, but for that you need to be cautious. You need to join regularly. Okay, like I started a revision series, then I found welding more students, casting less, forming less. Then what is the meaning? So that's why I reduced the frequency, because I feel you guys are also busy, I know that. So it's fine, but Vinay is saying B, Ishwar is saying B, Malesh is saying B, Papa Ghoda is saying B. Okay, so you guys are saying this is the answer. You guys are saying this is the answer. Look at the units. After that only answer. Look at the units, then only answer. Maybe after looking at answers, sorry, I feel here M is also there. This is missing. Now tell me. Now tell me. I have made a correction in the option. Now tell me. Okay. So my dear, first of all, here we need to use some strength of material. If we have a beam where P force is acting, then my dear, this deflection is calculated as PL cube upon 3 EI. And this deflection is happening without any initial force for the vibration. Here in place of load, we have the weight mg. So we can also write in our case it is as mg L cube upon 3 EI. You know, whenever we are having a point mass, as the beam is massless, we know the Rayleigh method. What Rayleigh method says? What Rayleigh method says? Omega n is square root of g by delta. So you would be having this as 3 EI upon ml cube. By looking at that, students generally answer this, but they do not see the units. If you say Fn, you need to go omega n by 2 pi, and then the answer will be D. Very good, guys. Moving to the next question, guys. This is a beautiful question. YouTube manometer, your favorite case. YouTube manometer, your favorite case. Will you try this? This is for D'Alembert. Here we will apply D'Alembert. As I said, every method application we will see. D'Alembert's. Try this, otherwise I will tell you. And if you like this case, I will do 1 to 2 more questions on that as well. Tell me, guys. This is a numerical answer type question. So I have already calculated the answers for you. So if you will tell me, I will match the answer. I have done it for you already. Solve it and tell me the answer. Then I will match the answer. Here calculations are required. It is numerical answer type question. Even they have made the figure for you. This is YouTube. In this, we have some fluid. And my dear, if you are going to displace this fluid by an amount of x, if we are going to displace this fluid by a distance x, it is much obvious that when that fluid will be taking the position here. From this level, it will be at 2x. So at this section, the weight of this fluid will be acting like restoring force because it will try to take the system back to its position. So what will be the weight of this? It is rho A 2x. A into 2x is the volume. Rho into volume is mass into G. This is the restoring force. What D'Alembert said? D'Alembert said mx double dot add the restoring force rho A 2G x. Then what is mass of the total liquid? Rho into total volume into G is not required. What is total volume? A into length of this tube. Then my dear, you can put it rho A L x double dot rho A 2gx. Equate it to 0, D'Alembert principle. Rho cancel out, area cancel out, and you can see x double dot 2g by L into x. What is omega n? 2g by N. They have asked in hertz. So 1 by 2 pi. .662 is correct answer, TPM. Dear, we need not to have rho value. In such cases, we need not to have the rho values. Okay. Look, dear, I am once again telling पापा का घोड़ा. देखिए कैसे करेंगे. Look, whenever you have this tube, initially you know that the level will be equal in both the sides. Level will be equal both the sides, है ना? So if you will be having this, there is no vibration without any external disturbance. So I am going to take this by x down. When you will be taking from here x down, then you will be reaching at this level. And from this level, it will go up by 2x because already x was there. So this x will also go up. So if it will go by 2x, so the weight of this will be acting here. Because here, only this much liquid, so pressure, you know, that will be equal here. So this extra will try to make it again into equilibrium. So that is the restoring force. Now you understood? Yes, Vinay. So we have such more question also, if you allow me. But these types of questions till now have not been asked in GATE. They will soon come. Like let us say we are having a free surface here and we are having the fluid. Let us see how many of you are good in fluid mechanics. Okay. And my dear, in this fluid, I am having a block like that. Block is having a mass of m and there is a spring. There is a spring. So my dear, if that is the case, you know, there will be no vibrations. There will be no vibration until you displace the system. So let us say you are going to take the system down. Take the system down. So my dear, when you will be taking the system down, so this kind of things, okay, I will make it better than this. Just give me. Okay. I am making it like that. Let us say we are having a mass like this. And we are going to have a spring like this. And my dear, let us say we are having here some free surface where inside this liquid is there. This is the homework question for you, okay? Like this. If this type of question will be coming, you know that if it is inside in water, then also it will be going like that only. You will be displacing it by X and you would be having the spring forces. But if you are having a cylinder like that, okay, and I am having a spring like that, and let us say this is like that, and inside we are having the fluid with the density of rho, and the density of cylinder is rho m. Then my dear, if they ask you the natural frequency, what you will do? I am just giving you a hint. You will be taking this cylinder inside by a distance of x. When you will be taking this by a distance of x, you know there will be a buoyancy force will be acting on that. So my dear, then buoyancy force plus spring force, they will be acting like the restoring force. So you can have this type of question as well. Is it clear? Is it clear? Are you getting it? Okay, ultimate tag word. Are you talking about this question? Please tell me that. Okay, don't worry. We will not take these questions right now. I will take that on some other day. I know it will be heavy dose for you. Okay. Okay, this question you understood? Everybody? Ultimate tech word. You have problem with this one? Very good, very good. Zakhmi Atma, you are also there. Wonderful. Good evening. Good evening. Good evening. Okay, okay, okay. Don't worry. So we will see whatever I have shown you that water wala question after that. Okay. We will see that. First, let us do whatever we learned today. Okay. So we are having this question now. And my dear, in this question, you can see we are having a spring with stiffness K. And we are having a mass M of disk. And we are having a point mass. First of all, tell me how many masses are present in the system. How many masses are present in the system? How many masses are present in the system? Don't worry, that water question I will take at the last. Like Zakhmi Atma have answered it now, I will take that in the last. I feel Zakhmi Atma, I have taught you those type of question na last time I feel. Yes. So there are two masses. So my dear, this is a point mass. This is a point mass. But this is distributed mass. So one is point mass, other is distributed mass. So when we have distributed mass, we cannot use the Rayleigh method, that is for sure. So Rayleigh method cannot be used here. Forget about that. There is no damper, it is natural vibration only. But still, we cannot use Rayleigh method. So my dear, here you would be having the options like either you can use the torque method or you can use the energy method. So for such cases, we will be using either the torque method or the energy method. So my dear, whenever we are talking about this, so if this is the mass which is, you can see a rotating body like that. So for this, if I write the kinetic energy of the system, it is going to be half m x dot ka square plus half I omega ka square. Am I correct? Can I write this? Because this will be having one kinetic energy, this will be having another kinetic energy, as there are two masses. What is the potential energy of the system? It will be 1 by 2 s x square. Stiffness is k, so half into kx square. So we have two kinetic energy, one potential energy. So my dear, if you would be writing the total energy as a component, if you will be having the total energy as the component of potential energy plus kinetic energy, then you can write it as 1 by 2 m x dot ka square plus 1 by 2 I. So my dear, let us say this is the disk. For disk, you know, I value is mr square by 2. But this mass is different than m. This is capital M. So I would be writing it as capital M. M r square. The radius is given as r square. M r square into omega square. Now, you know, if this mass is having a velocity of v, it is sure that this point will also be having the velocity of v. And you know, this point's velocity can be written as r omega. So v is nothing but r omega. So my dear, in that way, we can write this as v, which is x dot ka square, and plus 1 by 2 s x ka square, because the total displacement of the system we are assuming as x only. So my dear, total energy now you can write it as 1 by 2 small m x dot ka square plus 1 by 2 capital M r omega is x dot ka square. Then my dear, you can write plus half sx square. So can we find out the natural frequency? Total energy is equals to, this is m plus capital M. So we can write 1 by 2. Okay. If it is disk, it is mr square by 2. So it is mr square by 2. One more 2 will come. So I can write 1 by 2 m plus m by 2. Am I correct? Am I correct? Just make me your comments visible. Into x dot ka square plus I am having half sx square. Now total energy is constant, so dE by dt will be 0. When I will be doing dE by dt is equals to 0, it is going to be 1 by 2 m plus capital M by 2. I feel Zakhmi Atma, I have already answered it. X double dot plus 1 by 2 into s into 2x into x dot is equals to 0. X dot will go on, 2 will go on. So you will be getting omega n to be square root of s by m plus m by 2. Yes. Ha Zakhmi Atma, you can use that. You can definitely use that. Is it clear? Is it clear? Is it clear, guys? Is it clear? I have made, I feel, some mistake. I feel I have done some mistake because, yes, this is m r square omega square, this is x dot ka square. Yes. We will see, Anirudh, that. Okay. Yes. So my dear, actually it was, okay, r omega we have assumed it to be x dot, that's fine. Okay, there is no problem, but I would like to tell you that if we are going in the terms of theta, then this x can also be written as r into theta, and then we can go like x dot is equals to r theta dot. So we can go in the terms of theta as well. Okay, so I will be showing you one more way. Just wait for that. Just wait for that. I am telling you. Let us have one new slide. Okay, so we can also assume like we are having this and we are having this mass. Okay, and in this question we are having this stiffness K, and this is fixed like this. Okay, so my dear, like as you know, it is rotating like this. You can say this is r. So if this is going down by x, it is going to be rotated by r into theta. Let us say it is rotated by some angle of theta. So in that case, x can also be written in terms of r theta. So if we want to show it in the form of angular vibrations, then how we will be showing it? So my dear, you can write that as you have written the kinetic energy of the system. So in that way, what will be kinetic energy? Kinetic energy is half m x dot ka square plus half capital M r square omega square by 2. Now r into omega is x dot, so we can write it as 1 by 2 small m x dot ka square plus 1 by 4 m r into omega is also x dot ka square. Now if we write x dot is equals to r theta dot, then we can write in the form of angular. Then what will be the case? It will be potential energy is half Sx square. So we can write this equation as 1 by 2 m x dot is r into theta dot का square plus 1 by 4 m r into theta dot का square plus 1 by 2 s x square. X is r into theta. So r into theta का square is equals to 0. So then you will be getting this 1 by 2 m plus 1 by 4 m into r square theta dot का square plus 1 by 2 s r square theta का square is equals to 0. Then my dear, we will be going for the differentiation, as we are going total energy is constant. So we will be going for differentiation. So 1 by 2 m plus m by 2 r square theta dot is 2 theta dot theta double dot plus it is 1 by 2 s r square 2 theta into theta dot is equals to 0. Now theta dot will go on, 2 will go on, 2 will go on. So here you will be getting omega n in terms of angular vibration. It is going to be s r square upon m plus m by 2 r square. R square will get cancelled out. You will get once again the same. Is it clear or not? Please tell me that. Is it clear or not? I have shown you both the ways. Okay, the first way I have done like what I have done. Second way, like you can see, the answer was given by Jakhmi Atma. So I have done both the ways. Is it clear for everyone? Please tell me that. Some people would be thinking what sir is doing. I was showing actually both the ways to do it. Okay, sir, test series for mechanical engineering, how much of cost? Sai, I don't remember that. You can go to the BYJU'S exam prep app. There you will see the cost. Okay. Everybody understood, guys? आ रहा है कि नहीं? आ रहा है कि नहीं? Please tell me that. Great, Prasanna. So guys, now we have one more case, and this is a question based on torque method. This I will be doing. Those who know the torque method, they can try. Otherwise, I am teaching you torque method from this. Zakhmi Atma, identify your mistake. Either they are conceptual or numerical. Then we can work on it. Okay. So now, my dear, let us see how to solve this type of question. Actually, this rod is not a massless rod. This rod is having a mass m and length l. So is it a point mass? Is it a point mass? No. It is a distributed mass. So as it is a distributed mass, I cannot use Rayleigh method. I can use either torque method or energy method. In the previous question, I have used energy method. Here I will be using the torque method. So my dear, in reality, this is the rod. Let us give an angular displacement of theta to this rod. When you will do that, this torsional spring will also be rotated by the theta. So a restoring torque will be provided by this spring, that is Kt into theta. Then one more restoring force will be coming because of this spring. As this spring is compressed by some amount, that is L is the length of this rod. So by L into theta it got compressed. So a force will be coming as K into L into theta. This spring is expanded by the same amount. So this will also be applying a force in upward direction, that is K into L into theta. And you know, as this is the hinge point, we are talking about theta, about this point O. So my dear, restoring torque because of these two forces will be 2 into KL, okay, KL into theta into L. So it is going to be the restoring torque. Add D'Alembert component, I theta double dot. Like mx double dot is the D'Alembert component in the linear vibration. Similarly, I theta double dot is the D'Alembert method, D'Alembert component in the angular vibration. So we got the equation as I theta double dot plus Kt theta plus KL square 2 times into theta. So my dear, this is equals to 0. This is the equation. Now, if you want to find out the omega n, it is very easy to find out. It is KT plus 2KL square divided by I. Is it clear or not? This is how we can use the torque method if we are having angular vibrations. Okay. So my dear, with this we have completed all the cases of natural vibrations. Please tell me, everybody got some feel of that or not? Okay. So this question, I wanted to tell you that both the ways you will get same answer. Okay. That's why I have done it. Some people may be thinking why sir is doing it. To give you a feel of vibration. It is not difficult. It is just lengthy. Is it clear for everyone? Clear for everyone? Yes. So I am not here for the people who are judging me. I am here to give you those who already know that sir is going to give some quality questions. Okay. So my dear, this is relay method, and the last question of this natural vibration with relay method. Then we will enter into damped and force damped. For damped and force damped, I will just give you formula and question, because in marathon we cannot study in detail. We can just revise the things. So we will see that. हाँ भाई जख्मी आत्मा, good evening. Yes. Okay. So my dear, this is the question once again on relay method. So as you will see, there is a point mass. Just by looking at point mass, you will get a feel that we will be going with relay method, where we need not to apply any governing equation. We can directly write omega n is equals to G by delta naught. Here delta naught is the static deflection of mass. So we will see that this complete is one string. In one string, tension remain the same. Will you try this or shall I solve it? Will you try this or shall I solve it? Will you try this or shall I solve it? Tell me that. Shall I try this or will you try this? Yes. Ishwar, Malesh. A good questions. Tell me, yaar, will you try or shall I start? Everybody. Okay, try kariye. This is a good question. After that, I will solve that water question also for you. Okay, when we will be having a cylindrical body inside the water, we will solve it. Don't worry. Yes, TPM, your answer was correct. Your answer was correct. Are you talking about this question? Yes, it was correct only. So Zakhmi Atma, please try to connect with me. Okay, then I will be able to help you. You can share your test with me so that I can identify where you are doing the mistakes. Okay, this question answer you have given. This question answer where you have given. Okay, Papa ka ghoda is saying 1.8. मुझसे क्यों डर रहे हो यार? मैं तो आपकी हेल्प के लिए हूं, मुझसे डर के कहां जाओगे? Okay, so you are giving the answer for this as 1.8. But how it is 1.8 bhai? There is no values given na? There is no value given. How it is 1.8? Yes. Okay, G 9.81. Okay. I got it. You are talking about this question, I feel so. This you are saying. 1.662 is the answer for this. Okay. So dear, we will try this. Don't worry. So guys, first of all, you will see this pulley number 1. This is pulley number 2. On this pulley number 1, here we have tension T, here we will have tension T. Same string will be having same tension. Let us say upward tension is T dash. No issues. Then we have second pulley. Second pulley will be having tension T, as same string will have same tension. Downward tension will be T dash. Why T dash? Because for first pulley, this T, T dash is equals to 2T for equilibrium of the body. Here also these are 2 T's, so it should be T dash equals to 2T only. Then my dear, if you see the mass equilibrium, mass is having tension upward, mg downward for equilibrium. So we can see T is equals to mg. But we need to find out the natural frequency. For that, we will assume that this m is going down. Initial displacement, static deflection of mass is delta naught. So why it is going delta naught down? Because as this is the stiffness K1. So my dear, when this pulley will be coming in contact with this spring, because of the deflection of spring, let us say, sorry guys, this pulley will be going down by delta 1. If you see this pulley like this, if this pulley is going down by delta 1, the new position of the pulley will be this one. Can you feel it? That if this to this, this to this will be delta 1, this will be delta 1. So if this is delta 1, this is delta 1. So this entire string will be coming like now, like this. So this delta 1 and this delta 1 will be added to this mass, and this will be going by 2 delta 1. So can I say, because of this, delta naught is equals to 2 delta 1. But the same is happening on this side also. The same is happening on this side also. Because if this pulley will be moving to this situation, if this is delta 1, this is also delta 1. So here also 2 delta 1 will be going on. So can I say 2 delta 1 because of this spring, 2 delta 1 because of this spring? I will be having delta naught is equals to 4 delta 1. Is it clear or not? Please tell me that. Is it clear or not? Please tell me that. So I can write delta naught is equals to 4 delta 1. 2 delta 1 because of one pulley, 2 delta 1 because of the other pulley. Okay, Manoranjan, I will tell you after this question. Okay, after this question. So if we can write it like that, delta naught is 4 delta 1. What is delta 1? If delta 1 is the deflection of this pulley in upward direction like this, so this spring will also be deviated by that delta 1. So we can write that delta 1 or delta dash is equals to T dash by K2. Is it clear? You can also consider that if the stiffness is K2, this is not delta 1, let us say this is delta 2. So in that case, we will be having 2 delta 1 plus 2 delta 2, as the stiffnesses are different. Then my dear, you can write this delta naught as 2 delta 1 is T dash by K1 plus 2 T dash by K2. Then my dear, you know that as delta naught is 2 T dash by K1 plus 2T dash by K2. You know 2T dash is 2T by K1 plus 2 into 2T by K2. Then you know T is mg. So it is 4 T common by K1, 4T by K2. T is coming out to be mg, my dear. So you will be having 4 mg common. 1 by K1 plus 1 by K2. Is it clear for everyone? The answer will be 4 mg. K1 plus K2 by K1, K2. How many of you understood this value? Please tell me that. Omega n will be G by delta naught. Is this the correct answer? Papa ka Ghoda, Jakmi Atma, Vinay, TPM, please tell me. Ha. That's why TPM, I went slowly. First I assumed both to be same. Then I have seen, oh, stiffness is different. Oh, stiffness is different. So I said delta 1 and delta 2 are different. So slowly I am going ahead. Once you get the concept simply, I can add something into that. Very good. Papa ka Ghoda, you got or not? Because you have assumed some hypothetical values. Tell me. Yes, everybody. Shall we move on? Any doubt in this question? Papa ka Ghoda, don't apply such concepts. Okay? You need to do it like that. Okay? Don't go for hypothetical things. Okay, guys. Now we are moving to the damped vibration. But before we do that, we can also use that buoyancy questions. Like, let us say, as some student was saying that I have doubt into that. So I am telling that again. We are having this cylinder. Let us say it is having some density of rho m. Okay. A is the area, L is the length. And this water is having the density of rho, let us say. So if we want to find out the natural frequency of this system, how we will find out? So we will be displacing this system down by some distance of x. When you will be displacing it to the x distance. So if A is the area of that, what will be the extra volume it will be displacing? The extra volume it will be displacing is A into x. Okay, A into x is the extra volume displaced. Then you know what is the buoyancy force? Buoyancy force is the weight of the volume displaced. So density of water into A into x. So that will be the restoring force acting on this. D.L. Lambert said add my component into that, that is mx double dot. So you will write mx double dot plus rho of water A into x is equals to 0. You know mass of this cylinder will be rho into volume of this cylinder. What is rho? Rho m into x naught plus rho water A into x is equals to 0. What is volume of the cylinder? Area into length, x double dot. Okay, once again I am writing in the not reachable area. So density of metal is A into L, x double dot, plus rho of water A into x is equals to 0. Area is common, will get cancelled out. So I feel now you can see that x double dot is equals to rho of water by rho of m into L plus x is equals to 0. Is it correct? Is it correct? So can I write omega n is equals to square root of rho w by rho ml? Is it clear for everyone? Any mistake I have done, please tell me that. Any mistake if you find I have done, please tell me that. Yes, there is one mistake, or is it correct? Weight means we will be having G. So here we must have a G value. Here we must have a G value. Here we must have a G value. So here we must have a G value. I feel everybody understood that. So when I am doing calculation in front of you, itna mistake banta hai. ठीक है? Because I am not giving exam. I am doing in front of you to explain you. Is it clear? और ये मैं आपके सामने बनाया है क्वेश्चन, कोई घर से करके नहीं आया हूं मैं। यस, वी विल कंप्लीट इट जख्मी। हाँ, दैट इज ऑल्सो करेक्ट, दैट इज ऑल्सो करेक्ट जख्मी आत्मा। Everybody got it? Some student have asked, he didn't get how I have written mass as rho into volume. Now it is clear? It is clear? It is clear? Everybody, whoever is present in the class, have to write yes sir, clear. Then we will move further. This question I have made in front of you because you asked, sir, we have problem with such question. I have done it in front of you. ये क्वेश्चन था टेस्ट में, इसको और गंदा कर दे क्या? अगर आपको सच में मजा आ रहा है तो इसको और गंदा कर दे। यस, इफ यू आर रियली एंजॉइंग, डू यू वांट मी टू मेक इट फर्दर डेंजरस? टेल मी। या घबरा गए अब? ओके, इफ यू रियली वांट मी टू मेक इट स्लाइटली मोर डेंजरस, लेट अस सी. The same cylinder we are having with the spring now. The same cylinder we are having now with the spring with stiffness S. Now you will do this. Inside we have water with density rho. Density of this is rho m. Area is A, length is L. So as we have written previously the equation, rho m into x double dot. Okay, you will do first, then I will do. Otherwise you will say that you are not giving us the chance to do. Solve it and give me the answer. Yes. Solve it and give the answer. I am waiting for your answer, then only I will start. I feel some student have asked me कि उनको क्या समझ नहीं आया था. Manoranjan, are you there or not? Okay, so Manoranjan, till other students are solving, I am telling you this. As we have the water initially for this L height, L length, so we can write density into area into length. This is the mass. Area is constant, that's why. Okay, so my dear, for this, what will be the answer? When you will be taking it down by a distance of x, then there will be a buoyancy force in upward direction, which is rho into g into a into x. There is a restoring force due to spring as well, s into x. So D'Alembert component is mx double dot. So we will be writing mx double dot plus rho ag x plus sx is equals to 0. So mass is rho of m into area into length. This is density into volume, x double dot. Rho ag x plus sx is equals to 0. This time you cannot cancel the a, so you will be having the omega n is equals to square root of rho a g plus s rho m into a into l. This will be the answer. Everybody is happy with this new type of question? Are you feeling that you get something by joining this session? Are you feeling that this session is helpful for you? Do you want me to come up with more such sessions on other topics, obviously? Or say, sir, please don't come. We don't like daily. Yes. Fine. Okay, guys. So we are moving further, guys. So this was about the natural vibration. Now we are talking about the damped vibration. So my dear, I already told you damping is the technical name of kinetic friction. Kinetic friction means relative motion. Damper is the best representation of the relative motion. And my dear, we generally says that when we are talking about friction, friction eats velocity. So as friction eats velocity, if you take a ball and you are going to give motion it onto the earth's surface, after some time ball will come to rest because friction eats velocity. So can I say that damping force is directly proportional to velocity? That is why damping force is written as C into x dot, where C is the proportionality constant, which is damping coefficient, which is depending on the system, and it is denoted by C. So whenever we will be having both damper and spring and mass, these three things, it is said to be damped vibration system. For this, the equation is coming like mx double dot plus cx dot plus sx is equals to 0. As you know, here friction coming into picture, energy method not applicable, Rayleigh method not applicable. I will not go into the derivation, but after some derivation, we are getting it as x double dot plus 2 zeta omega n x dot plus omega n square x is equals to 0. This is the final equation of damped vibration system. And I am going to define some formulas which will be used for the calculation purpose. As I already told you that in this we have derivations. And if you want to see derivation, then my dear, I have already kept the derivation very deeply on the slides. You can check them. But finally, we are going with the formulas which will be required for the questions. Okay. So I am going for the formulas. Okay. But there are three types of dampings. For that, we will start the formulas first. We will be having a formula of degree of dampness. So degree of dampness, my dear, is defined as zeta ka square, where zeta is the damping factor. It is defined as C by 2m ka square by omega n ka square. This is degree of dampness. And zeta is defined as, if you will be cancelling the square with the square root, you will get C by 2m omega n. This is said to be damping factor. Damping factor. Then my dear, you know that this is zeta. We are defining it C and 2m. What is omega n? Square root of s by m. So that will give me C by 2 root sm. Then my dear, zeta, which is damping factor, is also defined as coefficient of damping by critical damping coefficient. If you equate this and this, you can say critical damping coefficient is 2 root sm. If you remember these formulas, you don't know what is vibration, you can solve every question. We also know one more formula is damped frequency. That is natural frequency into 1 minus zeta ka square. This is the damped frequency. As this is the exam oriented session, we are not going into overdamped, underdamped, critically damped system, because that is required for interview purpose. And don't worry, when we will come up for Gate 24 marathon specially, there we will teach everything. Here this is only exam oriented marathon where we need to go for questions and formulas of this type of things. So omega d is omega n square root of 1 minus zeta ka square. Then we are having a decremental ratio. Then what is decremental ratio? You know that underdamped system is like that. So here x0, here x1, here x2, here x3. Decreasing order of amplitudes are there. So we are having the decremental ratio. So when we are having the decremental ratio is defined as x0 by x1, x1 by x2, or any such ratio. And my dear, it is given as e to the power zeta omega n td. Here Td is the time period of damped vibration, which is 2 pi by omega d. And my dear, you know that when we are going for logarithmic decremental ratio, it will be 2 pi zeta upon square root of 1 minus zeta ka square. These are the formulas of damped vibration system. I feel everybody is okay with that. Is it fine? Shall we directly go to the questions? As I already told you, for damped and forced damped, we will not go for the interview part. Otherwise, you know how critically I enter into that. Over damped is used in door hinges. Critical damped is used in the rifles. Hai na? You can see there are a lot of applications shown. Okay, if you want to see. This is over damped. This is critically damped. Under damped. Okay, so that detailed discussion I am not going into. These are the applications if you want to see. This is for critically damped. This is for over damped. You can see this is without damper. This is with over damping case. Okay, so I am not going into that because that is the full class material. So this is a exam oriented marathon we are moving ahead with. Fine guys. So we are solving a question on that now. Then we will go to the forced damped vibration system. Sir, every year in UPSC mechanical questions, dear, from everywhere questions are coming. Actually, it is not fixed that from where it will come. This is the question. Try to solve it now. This question is saying, my dear, an exhaust fan rotating at 1000 RPM is to be supported by 4 springs, each having a stiffness of K, if only 10% of the unbalanced force of the fan is to be transmitted. Okay, sorry, this is from forced damped vibration. Yes, this is your question. This is your question from damped vibration system. Previous one was from forced damped vibration. If you guys want detailed marathon like on damped vibration, forced damped vibration also, you can write in the comment section after the session. If 5 requests will come, I will take that also. Okay. A spring mass system consists of a spring with stiffness 350, mass 0.35 kg. The mass is displaced 20 mm beyond the equilibrium position and released. The damping coefficient is this. Determine critical damping coefficient, damped natural frequency and logarithmic decremental ratio. I am writing the formula. Critical damping coefficient is 2 root Sm. Natural frequency is damped natural frequency is, and zeta is, decremental ratio is. So I am telling you, from these topics, the questions are very, very easy. Okay, Zakhmi Atma. Try to answer it, guys. I need answer for these 3 questions from damped vibration systems. All are formula based question. In this chapter there is nothing. Okay, it is all formula based. So Cc is 2 root Sm. We are given the mass 0.35 kg. We are given the stiffness. We are given the damping coefficient. Even we are given the tell me guys. Actually, when I go for damped and forced damped vibration, I take around 3 hours in that because there are detailed interview part. But for exam, only formulas are required. So here we are meeting for exam, I feel, because the feeling of the classes you have already taken. Okay, so here we are coming for exam perspective. So I'm not going into all that. I feel now it is fine. Now it is fine, guys. Okay, answer have already come from the side of TPM. And the answers are like, okay, so 49.497, let me check it. I have already solved it for you. 49.497. Are everybody getting the same answer? 49.497. Please tell me. I don't feel that answer is correct for TPM. Please give the answers, everybody. I am waiting for the answers. 22.135. 22.135 is correct. 22.135 is correct. Very good. What is damped frequency? What is damped frequency, guys? What is damped frequency? What is damped frequency? Damped frequency. Zeta will be coming out to be 0.632. Zeta will be 0.632. So 24.5. 24.5. Yes, very good, Ajit. Very good, Ajit. The last is delta. TPM, got your mistake or not? Manoranjan, are you getting it or not? Delta answer. Delta answer. Very good. 5.124. So guys, are you okay with this much discussion on damped vibration? For exam only this is required. Otherwise, you know, if you want, even my sessions are available on YouTube, where I have done the derivations of damped vibration, forced damped vibration. If you will search with the name of qualifier series, I have taken 2 years back. There I have done complete derivation of damped vibration, forced damped vibration. But I feel students are not requiring that right now. For the exam only you are looking for. Okay. So now we are going for the forced damped vibrations. Okay. Forced damped vibrations. So my dear, when we are talking about forced damped vibration, now we have unbalanced forces also. And that unbalanced forces are coming either from the rotating masses or from the reciprocating masses. Because if we are having the rotors rotating like this, and no material is homogeneous and isotropic, center of mass is not lying on center of, you can say, geometrical center, centroid. So as the mass will be lying eccentric to the centroid, so when it will be rotating with omega, there will be an unbalanced centrifugal force, which is me omega square. And when this rotor will rotate, the direction of this force will keep on moving, keep on changing. So when the direction will change, such force is fatigue force. Similarly, if you take a cylinder piston arrangement, there you must have seen piston is going to apply a force on the crankshaft, which is inertia force, and it is given as mr omega square cos theta plus cos 2 theta by n. And here theta is the crank angle. So this force is having theta in the equation. Theta is the crank angle which is keep on changing. So when theta will change, force will change. So force is having variable magnitude. So this is also a case of fatigue force. Fatigue force is either change in magnitude or direction. So if those forces will be present in the system, then my dear, vibration, you cannot avoid it. Vibrations are always present in the systems, and we say vibration in a running system can never be zero. So for these type of system, the equation is given like. I am going for the equation for that, don't worry. The equation is mx double dot plus cx dot plus sx is equals to f naught sine omega t, because that force will be harmonic function. And we can also write the equation to be x double dot plus 2 zeta omega n x dot plus omega n ka square x is equals to f naught by m sine omega t. As here left hand side is same as that of damped vibration system, but right hand side is different. So this right hand side will be giving particular integral, left hand side will give you complementary function, and the total answer will be the summation of that. So when you will be going for all this derivation, we will be having some very important results. First result is related to the amplitude of vibration. As I said, vibrations are always present. So when you will solve it, you will get the amplitude of vibration as I am showing it. The amplitude of vibration is this. It is f naught by s 1 minus omega by omega n ka square 2 zeta omega by omega n ka square. Here omega is the forced frequency. It is the frequency by which the rotor is rotating. It is the frequency by which your system is running. It is the frequency by which your crank is rotating. Omega n is the natural frequency of vibration. And we can call this omega by omega n ratio to be equals to r. So we can also write this as f naught by s divided by square root of 1 minus r square ka square plus 2 zeta r ka whole square. If you want a detailed session on that, I already told you, if 5 students will comment in the comment section, I will take that also in detail with all the concepts, with the derivations, if you want it. Otherwise, for exam, it is enough. Then we are having a magnification factor. So my dear, magnification factor is going to compare the amplitude of force damped vibration systems vibrations magnitude to the deflection of only spring. Like if I am having a spring mass system with the damper with the unbalanced force, then you know that we have found out the amplitude of vibration as f naught by s divided by square root of 1 minus r square ka square plus 2 zeta r ka whole square. Then my dear, you know, if we are having a only spring and we are applying a force f naught onto that, then this will be having a deflection of f naught by s. So the ratio of this amplitude to this deflection is magnification factor. Actually, it tells how much bad this vibration system is as compared to this. So that ratio is a by f naught by k, and you know f naught by k will get cancel out, f naught by s will get cancel out, and you will be getting this as magnification factor. Okay, and my dear, graphically we can show it like this. You can see when you will be making on y-axis magnification factor, on x-axis you will show the r, that is omega by omega n, and my dear, this is the r is equals to 1. This is magnification factor is equals to 1. You will see when you will put in this formula r is equals to 0, you will get magnification factor will always comes equals to 1. Because when r is 0, this term 0, this term 0. So every curve will be starting with 1 only. So when r is 0, magnification factor is 1. But when you will be changing the zeta 1 by 1, the curve will be changing. So you will see that this will be the curve obtained for zeta is equals to 0. You can see zeta is there in the denominator. So as the zeta will increase, overall value will decrease. Okay. So in that case, we can say when you will be increasing the zeta, I am changing the color. When you will increasing the zeta, then this curve will go down. When you will further increase the zeta, this curve will more go down. When you will be once again reducing the zeta, curve will go more down. If you will once again reduce the zeta, like this curve will be coming when zeta is more than equals to 1. White one will be coming for zeta is 0.3. Blue one will be coming for zeta 0.6. This will be coming for zeta 0.9. This is the case. Is it clear for everyone? This is about magnification factor. So you can see magnification factor will be reducing if you are increasing the zeta. So obviously having zeta more will reduce magnification factor, will reduce the amplitude of vibration and increase the life of the system. So for this we learned, if we want more life of the system, we need to keep zeta more, because zeta will be a kind of friction damping factor. Okay, so that is the case. Moving further, my dear, so this question I have already done for today for you guys. I wanted to do that, I have already covered. Okay guys, so now we are moving to the next thing, that is transmissibility ratio, that is for vibration isolation. So I will be taking someday a session on only force damped vibration, then I will go into all detail. For the timing we are completing it with the formula only. So there is a transmissibility ratio. If we are going to have a machine like this, I am telling simply in 2 minutes. If this is a machine M1, this is machine M2, this is machine M3. Let us say machine M1 is running. When a machine is running, vibrations are going to produce, because machine have some rotating and reciprocating components. So these vibrations will be producing and transmitting to the earth. Earth will be giving that same to the other machines. So other machines without running are feeling or facing the vibrations. Vibration reduces the life. So M1 is running, but without running, M2 and M3 are suffering. Like whenever you go with your friends group, your friends are smoking, you are just standing with them. So they are having the issue of smoking. You know, smoking causes cancer. If they get cancer, you know, smoking gets cancer. They were smoking, they were knowing that. You were just standing with them. It was passive smoking. You were not directly smoking, but that was going inside you. Why? Because you were standing there. So my dear, you are affected, you are affecting by that smoke without taking that actively. Passively you are getting affected. Similarly, these machines will be affected by the vibration of this machine. But we want to save these two machines from the vibration of this. So how we will solve it? We will be providing for this machine a vibration isolation. Okay, this is a vibration isolation. So now this machine will be transferring a force Ft to this, and vibration isolation will be transferring F0 to the earth. So my dear, we are defining the effectiveness of this as transmissibility ratio, and it is defined as the ratio of Ft by F0. We expect the force transmitted by machine to the isolation is F0. It is Ft. So we want that Ft should be less than F0. So transmissibility ratio should be less than or equals to 1, but not more than 1 in any case. So my dear, this is the transmissibility ratio concept, and the formula for that is coming like this. So one more last formula is the critical speed of shaft or whirling of shaft. So Y is, E is the eccentricity. Eccentricity, like you have the rotor, and let us say center of mass of the rotor. This is the rotor on a shaft. Center of mass of the rotor is E distance away from the center of shaft. Then the Y deflection is E by omega n by omega ka square minus 1. This is coming as the Y, that is deflection. And my dear, this omega is equals to omega n is the condition which is said to be critical speed of shaft. I feel everybody would be remembering. Here I give the example of doctor, hospital, I give the example of laptop, and I give you example of power plant shaft. We are not going into that as it is revision marathon. But yes, as per your request, I will be teaching you one day 2 to 3 hours only force damped vibration. Then I will give you all the practical application. What is the work of governor? What is the work of power plant shaft? How they are going to work on it. Okay. So this is the completion of force damped vibration system. Now we will be completing with one question, guys. Last question we are having with us. this is the question, guys. An exhaust fan rotating at 1000 rpm, so omega is 2 pi n by 60 and is 1000 rpm, supported by 4 springs, each having a stiffness of K. If only 10% of the unbalanced force of the fan is to be transmitted, Ft by F naught is 0.1. This is transmissibility ratio. What should be the value of K? Assume the mass of exhaust fan to be 40 kg. You can find out, guys, the stiffness. You know, transmissibility ratio is, there is no zeta given, C is 0, okay, C is 0, there is no damper given. So you know the formula for transmissibility ratio is 1 plus 2 zeta r ka whole square 1 minus r square ka square plus 2 zeta r ka whole square. Zeta is 0 here, so you will be getting 1 by 1 minus r square. So you need to find out the value of r. R is omega by omega n. Omega is known to us. Omega n is root k by m. You will be getting the value of K. This is the question, guys. As they have not mentioned springs are series or parallel, you can directly give the total stiffness also. Solve it. The last question from my side. Then we will stop the session. As I promised, it will be not more than 2-hour session. And as I already said, if you really want damped vibration, force damped vibration in detail, like I have done with natural vibration, you want the physical detail, because if you see last 2 years paper, they are not asking from the formula, they are asking from the concepts. If you want that detail of natural vibration like you have seen, message in the comment after the class. I want to see how much you really want. Okay, if 5 comments will come, I will take. Solve it. Zakhmi Atma have answered it 9969.63. Wonderful, guys. Very good, guys. So honestly tell me how you found this session. Then we will close this session, and before leaving, do like and share. Honestly tell me how you find this session. Useful or not? जख्मी आत्मा, आप पहले तो टेस्ट को टेस्ट समझना छोड़ो, ठीक है? यू आर एक्चुअली सफरिंग विद fear, because if you can solve the same question here but not in the exam, it means you have the fear of exam. You just need to work on that, and for that you need to take the test casually, but make a habit that in casual also you will not be selecting the answer until you get it, because you are stucking into the negative marking. I know that. So you need to make 2 rules. First, test you will be considering like a session only, and second thing, you will be writing or ticking the answer only once you get it. Okay, so the seriousness of the exam is required while giving the correct answer, and the enjoyment of the class is required during the solving. सोल्व करते समय क्लास फील करो, टिक करते समय गेट का एग्जाम फील करो. गेट का एग्जाम फील करोगे तो नेगेटिव मार्किंग से बचोगे, और क्लास के एंजॉयमेंट में रहोगे तो क्वेश्चन सोल्व करते समय प्रेशर नहीं रहेगा. एंड दैट इज द हाइपोथेटिकल कंडीशन इन विच यू नीड टू पुट योरसेल्फ इनटू, क्योंकि फियर भी हाइपोथेटिकल है. कल का जो डर है आपको, वो भी तो हाइपोथेटिकल है ना. कल का क्या होगा तो कल ही पता लगेगा. तो जैसे वो डर हाइपोथेटिकल है, आपको हाइपोथेटिकली अपने आप को तैयार करना है. जब भी आप टेस्ट में बैठो, बस ऐसा समझो आप क्लास में बैठे हो सोल्व करते समय, ठीक है, और टिक करते समय ये मान के चलो कि आप एग्जाम में बैठे हो गेट में, तो टिक आप सही आए तभी करो, वरना मत करो, क्योंकि नेगेटिव मार्किंग आपको ले डूबती है, जहां तक मैं समझता हूं। एक बार ये करके देखिए, ठीक है, एक पेपर में करके देखिए इस हाइपोथेटिकल चीज को। हाँ विनय, बट दे हैव नॉट मेंशन्ड अबाउट दैट दे आर इन सीरीज और पैरेलल। Okay, that's why this is the total stiffness. But if they say 4 springs are attached, you can divide it by 4 as well, by assuming that they are in parallel. Can we do like that? Yes, that is the only way. Otherwise, they have to mention, they need to give the figure. They have not given the figure. Clear, guys? कोई कह नहीं रहा है कुछ, सर हमें सेशन कैसा लगा? ठीक ही है सर, ले लोगे तो आ जाएंगे। ओके, फाइन गाइस। हाँ हाँ हाँ, श्योर श्योर लक्ष्मी आत्मा। ग्रेट गाइस, सो हियर आई एम लीविंग यू। ओके, ठीक ही लगा। ओके फाइन, so guys, here I am leaving and we will meet again for some other session in the upcoming days. Okay, so goodbye.